the substances that provide a deriving force for a chemical reaction. The organic molecule, when it is mixed with an organic reagent, it is converted into the product. Basically, the organic molecule is not a reactive substance. When it gets some organic reagent, which is an attacking reagent, it attacks the organic molecule, and then organic molecule becomes reactive. Then it reacts and it forms the product. We have two types of organic reagents, the electrophile and the nucleophile. Now we will discuss them one by one. First of all, we will discuss the electrophiles. Electrophiles are the species which have electrons deficiency. They are deficient with electron. The electro means electron and phile means lover. So they are electron lovers because they have electron deficiency, and they want to get some electron. Whenever they are present in the solution or in the mixture where any species has electrons, they readily attack that species and make that species reactive enough to give a certain product. So electrophile is a reagent which derives the chemical reaction by attacking on the electron part. Some electrophiles are positively charged like Cl plus and CH3 plus, and some electrophiles are not positively charged. They might be neutral. For example, the positively charged electrophiles are CH3 plus, Cl plus, bromine plus, and NO2 plus. They are positively charged. They have you can identify them from their charge. They are positively charged. Obviously, they lost their electrons. That's why they have a positive charge. By looking into the structure, we can find out why they are positively charged and why they act as an electrophiles. Now, if we draw the structure of CH3, we know carbon is a tetravalent. It belongs to group number 4 of the periodic table, and normally it forms 4 bonds. But in CH3, it is making only 3 bonds with 3 hydrogen atoms, and this makes it 6 electrons in its valence shell, which makes it deficient of 2 electrons, because every atom wants to have a complete octet. So it has a deficiency of 2 electrons. That's why it is electron deficient, and it acts as an electrophile. The second type of electrophiles are neutral electrophiles. Neutral electrophiles like BF3 and carbon dioxide, they have no charge on them. They are neutral atoms, but they are electron deficient in nature. Now, by looking into the structure, we can identify why carbon dioxide is electron deficient and why BF3 is electron deficient, and why do they behave as electrophiles in the solution, in the reaction. So as you can see, carbon is a tetravalent atom. It makes 4 bonds. So carbon is in the middle, and it is bonded to 2 oxygen atoms, and it makes a linear molecule. So oxygen is a highly electronegative atom, and oxygen pulls the electron density towards itself. So on both sides carbon has 2 highly electronegative atoms which pull its electron density, which the electron density will be more closer. The pairs of electrons being shared between the atoms will be more closer towards oxygen, so carbon will be electron deficient. Now let's look into the structure of BF3. Boron is present 3, and it has 3 electrons in its valence shell. When it shares its 3 electrons with 3 fluoride atoms, it attains 6 electrons in its valence shell. But that does not make its octet to be completed, because by having 6 electrons, it still has the deficiency of 2 electrons. So their electronic configuration makes them electron loving. The electron deficient and reactive species Now the other type of reagents are nucleophilic reagents. Nucleophilic reagents, just like ammonia, they have electron, they are sufficient in electron, they have more electrons, and they have excess of electrons. They look for the positive charge. They are positive charge lover, the nucleus lover. That's why they derive a chemical reaction. They speed up the chemical reaction when they find some species which is positively charged, and the positive charge attracts them because they have plenty of electrons, and plenty of electrons means the plenty of negative charge. The negative charge attracts the positive charge. Nucleophilic reagents may be negative, may be neutral, and may be ambivalent. Negative. First of all, we are going to discuss the negative nucleophiles like H negative, OH negative, and RO negative. The hydride, alcohol, and alkoxy anions. As their charge shows that they have excess of electrons, they have plenty of negative charge. The neutral electrophiles have no charge, like ammonia and water.